Hey, welcome back to Fan Mama Physics. In this video, we're going to talk about more exponent laws. This is exponent laws number 2, section 2.5. We're going to build off of some of the rules we learned from the previous set of lessons. And in this one, we are going to look at what happens if we have brackets with an exponent outside of those brackets. So again, of course, there's always going to be an accompanied board game here that I will feature, and it has to do with the concept of essentially what students forget a lot, which is making sure that exponent gets distributed to every single thing inside the brackets, which of course we'll talk about when the specifics in the lesson. So the board game that I have here is called the Year of the Dragon, and very fitting for the time of this video that's been being recorded is during Chinese New Year. So of course, here we go. I am going to begin. So here's the board, and of course, we want to see the... I'm gonna make a mess, unfortunately. I just did. Here's what the board, the box looks like. So it's called Year of the Dragon. Stefan Feld games are very point county and the mechanics are quite rigorous. So he does a very good job. Rio de Grande Games, also great publisher as well. This is a classic, very classic board game. Plays up to 5 players, but I've only set up for 2 players because it gets lots of stuff to do. So the what's the purpose of the game? Well, of course, the purpose is to win, but to collect the most points as well. So how do you collect points? Essentially, imagine you are a particular group of like a town or city or a group of population and whatnot, and of course you want your population to do well. The better your population does after the course of 12 months, as indicated by the 12 tiles here, then you win. And of course, doing well should translate into points, which of course allows you to win the game. So here is a basic setup. So I've set up for 2 players. You start with some money. You start with You started with two buildings here. You actually start with 2 people, and there's actually too many people here for 2 players. They're supposed to scale according to the number of people in the game, so that the people that you buy or the people that you can get are scarce. So I forgot the setup for 2 players, but I think it's 1 and 2. So 1 at the top, 2 on the bottom, and notice the difference here. The top has a smaller number compared to the bottom, but the top gives you 2 icons versus 1 icon. Usually we call the bottom the younger people and the top the older but more experienced worker, or whoever they are. Okay, so the game progresses for 12 months, as I mentioned. Notice at the end of each month there is an event. The first 2 is peace. Then we get some fireworks, or the Year of the Dragon, or some festivities. This is contagion, so disease strikes. This is drought. This is imperial. This is an imperial tribute, so you have to pay money here. This is invasion by Mongols, and that's it. So it's 2 of every one of those. Okay. In the middle here, you see there are some actions that you take. I've grouped them into 2 for specific reasons, but the action here is conscripting or getting more military points. This is buying privilege, getting money. This is doing some research. This is building upside down. This is producing fireworks, and of course, this is producing food or rice. Here are the company tokens, the people, and then of course middle here this is the classic Feld track, meaning the Feld track gives you initiative. So the higher the initiative, you can go first, etc. So here's the basics of the game. So in 1 turn, what happens? At the very beginning, of the game, the people draft some people. So let's say this person drafts this Okay, and of course, drafts 2 people. I think it was 2 people. Maybe I got the rules wrong. Let's say this person drafts this, and it's determined by their choice, of course. So let's say that was the case, and then so the initiative points are written on the bottom. So this person would have initiative 8 points, and let's say that's purple. So felt track here is in the middle. Green only has 2. So there you go. Okay, so each person has, of course, availability. Okay, so so we have some firework person, makes fireworks. This guy has to do military. This is the monks, has to do with the points at the end of the game. This is the tax collector or whatnot. He makes money for you. This is a court lady. She generates privilege or points after every turn. Builder, good for building buildings. This is the researcher or scholar. This is medicine. I forgot what's the name, but basically produces medicine. And then of course the farmer, apothecary or whatever. Apothecary is very UK, but back then. Anyway, so after you determined kind of your set of people, then you have essentially purple, who is first on the initiative. Purple gets to go first. He picks either this group of actions or that group of actions. So he gets to pick first, which is nice. Maybe he goes here, and let's say the green goes over here. Then the purple picks one action out of these 3 to conduct. And then that could be build or whatever. If he builds, then he picks one of, he creates or builds another one of these. So he builds that on top for some reason. So you can have a building up to 3 floors. So there you go. That's his build action. Let's say this person decides to, I don't know, do some military. Or that's actually a really dumb move. But anyways, or get money. Or buy a privilege. He can buy a privilege. Privilege is, I believe, $2 for a small privilege and $6 for a bigger privilege. So he could spend all his money for that. That's up to him. Let's say he does that. Whatever. So that's what the action does. Then after that, if that's changed the track a little bit, then it hasn't. Then the next time, then the players pick people. So purple is still first on the track. So purple from his hand of cards chooses which person he likes to hire. So let's say he picks a court lady too or something. So he discards that, grabs a court lady, puts it into his palace, and notice that this player here can't do that because he doesn't have any more space. So he can still hire somebody. Let's say, I don't know, he chooses fireworks for some reason. Then he takes one of these tokens and he has to kick somebody out. It's a very terrible play, but let's say he had to kick the medico out, which really sucks. But anyways, let's say that's his turn. Okay, so after that, then we evaluate kind of the end of the month. This happens, which is peace, nothing happens, and then we count the points. Court ladies give you points, privileges give you points, the number of sets of buildings give you points as well. Notice that at the end of every month, some of the things are really bad. For example, fireworks is not bad because you just compare the number of fireworks tokens that each player puts in, and of course you get points based off who has the most. This one here is you have to pay 3 of these guys, so you basically have to kill 3 of the people, and of course for each of these motors you get to kill 1 less person that dies from the contagion. This is drought, so every pagoda or every building or palace you have to pay 1 bag of rice, which tokens look like these, and for every rice you can't pay there's some penalty. I can't remember what it was. I think you have to kill somebody or whatnot. This is paying the tax collector, I believe is $4, so you have that $4 by the end of this round. Mongols come and invade you, so you get a number of points according to how many military hats that you have, and the person who has the least military hats of all the P players loses a person, I think. So basically you lose a war, you gotta pay up. Okay, so that's kind of all of the different the different events. So why do I pick this game for the purpose of exponent laws? The reason is because I thought these monthly events were very interesting, meaning that these events are applied to every single player. Just like an exponent outside of a bracket is going to be applied to everything inside the bracket. Distributing everything is distributed equally amongst everyone, and that's the theme that I'm going off of for this particular lesson. So sorry it took a bit of time. It's a very there's a lot of components to this game. It is a well-designed game, lots of fun, just very hard to get a group of people to play now because of times, of course. So there you go. That is Year of the Dragon. And I just lost my box. Okay, here you go. All right. So, coming back to Exponent Laws number 2. Alright. Unfortunately, not going to have time to clean this up very much properly, but going to do our best here. Okay, so there you go. Yeah, I went through that definitely too quickly, but again, I just wanted to show the key thing, which is all of the events are applied to every player. Just like our scenario here. Let's take a look at each of these exponent laws, starting with power of a power. So let's take a look at what this is. What this means is if I have a number or I have a power and it's raised to another power, so in brackets, and then raised again to another power, then what do we do? How do we deal with the exponents? In this case, we would have to multiply the exponents to give us the total power. And again, most of these examples feature numbers, and of course, you're thinking, oh, I just plug it into my calculator, right? But there might be cases where you cannot. For example, let's say I have x to the power of 3, and then I raise this whole thing to the power of 2. In this case, I would have to multiply 3 with a 2 to give me a total of 6. Okay, not 5, that's the previous rule. Okay, how would you get 5? Then it might look like this. X to the power 3 times x to the power 2, that gives you x to the power 5. So that is very different. The reason why, let's take a look at an example here below. So according to what they have here, they have 3 to the power 4 and then raised to the power 4. So what that means is I have to multiply 3 to the power 2 by itself 4 times. So that's 1, 2, 3, 4. And now what we can do is we can use the previous exponent law to figure out that since I am multiplying these powers with the same base, I just have to add their exponents. So therefore 2 plus 2 plus 2 plus 2, and that gives me a total of 8. Or in other words, it is 2 times the number of times it appears, which is 1, 2, 3, 4. So 2 times 4 gives us 8. Okay, so this is why we have to multiply the exponents when dealing with brackets. Okay, so let's see here. So what happens when we have, say, multiple things inside a bracket? And this is what the game was there to show you, how every event, just like how every exponent is distributed to every single component, everything, every individual inside those brackets. So here we have an example where I have 3 times 4, then raised to the power 5. Then what needs to happen is I need to, anything that is multiplying or dividing each other inside the brackets, we have to apply the exponent to every single thing. So that means 3 to the power 5, 4 to the power 5, evaluate that, multiply that out, etc. Now, here are some other examples. For example, let's say you have 3a, 3a raised to the power 2. Now, 3 is technically multiplying a. Remember I said everything that's multiplying and dividing each other must be raised to that same power, must have received the effects of the exponent, or the exponent has to be applied to each and one of them. So here I get 3 to the power 2, distribute here, distribute to the a, and I get a to the power 2, So this is going to give me a total of 9a squared. Okay, so that's important to note, that the exponent applies not only to numbers but to variables, to anything inside the brackets that are multiplying one another. And of course, if you don't believe that, well then take a look at the example. Okay, you can try to punch this out in your calculator. You'll notice that even after you take 12 to the power of 5, that's going to give you this huge number here. Okay, so it works. It always works. Okay. Oh, and here you go. This is essentially what that looks like. Okay. And I did say division is also applied here as well. If you see anything that looks like this means this whole thing is bracketed. It just looks kind of funny. So again, if something is dividing something else, we also have to apply that exponent to everything inside of the what we call the quotient. So if it looks like this, like say 1 over 9 or 1 over a to the power of 2, then that's going to look like 1 to the power of 2 over a to the power of 2. And you're like, oh, 1 to the power of 2 is just 1, silly. Yeah, you're right. But what happens if I give you something that looks like this? Let's say I have b over 9 to the power of 2, then that 2 is applied to everything inside. So I get b to the power of 2 and 9 to the power of 2, which is just b squared over 81. Okay, so making sure that squared is applied, that exponent is applied to every single thing, every single number inside the brackets. You're wondering, what about plus and minuses? That's not this year. That's next year in grade 10. We use a different strategy for that. So let's take a look at some examples. Write each expression as a product of powers. So again, read the instructions carefully. When you see this question, it doesn't necessarily mean to give me the answer. Oftentimes you will lose a lot of credit for that, because the purpose of the question is to see whether or not you can apply exponent laws. And if you can't show that, I know you can type things into a calculator, but I need you to know whether or not you can use exponent laws. So in this case, 2 times 4, these two are multiplying one another, therefore 3 must be applied to every number that is being multiplied, including the 2 and the 4. So I get 2 to the power of 3 times 4 to the power of 3. Notice the instructions don't even tell me to evaluate. I can just leave my answer as this. Same thing here. I apply the 2 to the negative 4 and to the negative 6. I get negative 4 in brackets squared times negative 6 in brackets squared. And this doesn't even tell me to simplify. So I don't even need to simplify this. I just leave it. Okay, same thing here. I get 1 to the power 2 over 4 to the power 2. This is just equal to 1 over 4 to the power 2. Same thing with b. I'll get negative 9 on top to the power 4 over a negative 3 to the power 4. Don't need to evaluate. Last but not least, example 3. Why is the value of this thing negative? Explain. Ooh-hoo-hoo. So yes, we often are not very good with explain questions because we oftentimes tend to miss certain details or certain steps in the thinking process. So we know that let's talk about the inside. First of all, we know that negative 3 to the power of 2, this is just negative 1 times 3 to the power 2. So whatever's inside, this is going to be positive. This is going to be negative. Okay? So inside the brackets, we have something that's negative. Anything that's negative raised to the power of 3 is going to give us a negative times a negative times a negative. And that's going to give us a final answer that is negative, since there's an odd number of negatives. Negative times negative is positive, and positive times negative again gives us a negative at the end. Therefore, our final answer is negative. If I have to type all that out, or if I had to write that out, maybe in least amount of words possible, because of course, if you were asked to do on this test, you don't have access to a computer to type it out. So this was what I would write. Okay, so here we go. If you had written this, this would give the complete explanation. Since negative 3 to the power 2 is negative 1 times 3 to the power 2, the number inside the brackets is a negative number. A negative number raised to the power of an odd exponent is always going to give a negative answer. Okay, so that is how I would phrase that. Okay, so notice one step at a time in terms of the thinking process. So this is a bit of a lengthy video, I guess had to do with the game that I introduced. Year of the Dragon is a great game, but at the same time, don't forget to distribute the exponent to every single thing inside the brackets. I thank you for watching. I wish you good luck, and please stay tuned to part 2 of section 2.5, exponent law number 2. Thank you for watching. Fan of Physics signing out.